Hi, everybody. We're going to do U.6, which is from the U section, Systems of Linear Equations, from Algebra 1 IXL, and it's classify a system of equations by graphing. I didn't preview it, so it's going to be a bit of a surprise. Let's see how it looks. And we're supposed to graph them and click the select points. And, oh, okay. Basically, they just want to test your vocabulary more than anything. Consistent and dependent means infinite many solutions because consistent just means it has solutions and dependent means it's the same equation. Consistent and independent have a solution, but they're two different graphs. So those are intersecting graphs. And inconsistent are the parallel lines. It's the exact same as the one earlier with the number of solutions, it's just different vocabulary. So let's do a connection with the vocabulary. Consistent literally means it has at least one solution. Dependent means it has an infinite number of solutions. So for those of you who did the other section and want to compare it with this one, it's the same thing. Consistent and dependent mean that they are two lines that are on top of each other or basically the same exact equation. Consistent and independent has one solution, and that is a pair of independent equations just has one solution, and they look like this, where there's one solution. Infinite number of solutions look like this, with the other line in the exact same place. And inconsistent are parallel lines that have no solution at all. So this one would be no solution on the bottom. Hopefully you can see it okay. It's no solution down here. I don't want to touch them because if you touch them too soon, then it may count them against me. So anyway, let's go ahead and turn this off. I'm going to go ahead and I'll just turn it off. We'll bring it down here. Okay, so we're going to do the blue equation first. I am going to graph using slope and intercept. Hopefully you already know how to do that. The intercept is 0, -2, and we're going to count the slope. We're going to go down 3 over 4. And I'm going to go ahead and write just a little something here about it. Can't help myself, got to explain something here. First of all, this negative that you see in front of the -3 over 4 really belongs with the numerator. Now you can put it in the denominator if you want, or stick it out in front like they always do in the textbook. But it's much easier to understand when it's in the numerator. And if I put in 0 for x, then 0 times anything is 0, and y is equal to -2. That's where that 0, -2 comes from. Now I'm going to count my slope. From 0, -2, I'm going to count down 3, 1, 2, 3, and over 1, 2, 3, 4. That is a slope of down 3 over 4. Notice that I always go to the right because that's a positive value. Now you could have gone up 3 and back 4, which would be up 3 and left 4. And you can see that if I go up 3 and left 4, I end up over there. Anyway, that's the first equation, and I'm not going to go into any more detail. We're just going to do the second one. Now, this one says we're going to go through 0, -1, which is our y-intercept, and we're going to count down 3 and over 4, down 1, 2, 3, and over 1, 2, 3, 4, which makes my two lines parallel. Now, parallel lines, remember, are inconsistent because they have no solution. If you see no solution, it's inconsistent. Oh, looks like I have to submit. Little vocabulary, that's all. This one has the same slope with different intercepts. So this means they are inconsistent. So they have no solution. Now I'm going to graph them a little quicker this time. Let me get rid of this real quick. We're going to do the blue one first. It's going to go through 0, -8, has a slope of -1/2. This one, the orange, is going to go through 0, 3. It's going to have a slope of -1/2. And it's a little harder to see, but they are parallel and they are inconsistent. Remember, parallel lines have no solution. Okay, so this one, we'll go ahead and look at the colors here. So I'm going to do this one first. This one goes through 0, -1, has a slope of 1. There's my green equation. My blue equation goes through 0, -3, and has a slope of up 2 and over 1. And you can see that we have one solution, and the solution happens to be a 2, 1, but it has one solution. And these are independent lines. That's how you can tell. They're two separate lines, makes them independent, and they're consistent because they have a solution. So that is consistent and independent. Oh, here we go. Y equals -x and y equals -x, we call that situation a dependent situation, and it has an infinite number of solutions. It is really the same equation. So y equals -x goes through 0, 0, and goes at 0, down 1 over 1. That's a -1 slope. And you do have to graph the blue one as well. So make sure you graph them both. And there they are, one on top of the other, and they are consistent and dependent. They have an infinite number of solutions of the form of where the x's and y's have different signs. Same value, just different signs. So like 3, -3, 4, -4, -4, 4, and so on. That is consistent and dependent. All right, same slope, different intercepts. These are parallel lines that don't intersect. They are inconsistent. Consistent and inconsistent mean they have solutions or have no solutions. So the blue one goes through 0, -4, has a slope of -1. The y value, the y orange equation goes through 0, 1, has a slope of -1, and they are parallel, which makes them inconsistent. No solution. Be careful. A lot of times on tests, they'll make the lines look parallel, but they'll have very slightly different numbers. So pay attention to the numbers. These are the same, so they're dependent. They are consistent, but they're dependent. Same line. They both go through 0, -6, and have a slope of 1/2. Goes through -6, has a slope of 1/2. And we say they are consistent and dependent. Same equation. Consistent and dependent, same idea. This time, instead of using the slope and intercept, we could use intercepts. Here's using intercepts. If I put 0 for x, I get -2 for y. If you want to see this in more detail, just take a look at standard form equation graphing. If y is 0, x is 4. Basically, what I'm doing is just covering up part of it. 0, -2 is right there, and 4, 0 is right there. So there's one of our lines. And of course, that's our blue line. Now we're going to do the green line in the same place. And there they are. They both go through 4, 0 and 0, -2. And you can see why if you think about the numbers. And they are consistent and dependent because they're the same line in standard form. All right, I suspect that these two are maybe the same equation, or let's see, nope, they're going to be same slope. But let's go ahead and graph them just to see how they work out. So let's graph this one using the intercepts. And so I'm going to go with the orange equation, and I'm going to put x is 0, then y is 2. Notice what I'm doing. I'm just putting 0 in for x and solving for y. Then I'm going to put 0 in for y and solve for x, which gives me -4. Now I'm going to graph the blue one, which goes through 0, 8, and has a slope of 1/2. And we can see they're parallel. They both have a slope of 1/2, and that makes them inconsistent, doesn't it? They have no solutions. All right, we have different slopes, different intercepts. That means that we have one solution. We say they are consistent because they have a solution, and they're independent because they're different lines. Let's graph them. 0, -5 on our green one, and has a slope of -2/3. There it is. -3 on the blue one, And we have a slope of negative 1/3, which is right there. And we can even see what the solution is. It's going to be at -6, -1. So there's our solution, and it is consistent and independent. All right. X plus y equals -3. A lot of people are just going to solve that for y and just write it that way, which is fine. If I solve this for y, I just subtract x from both sides, -x minus 3, which is fine. You can graph it that way. You can also use the intercepts, which is the way I'm going to do it. Let's go ahead and go down here and get rid of this. So I'll graph the green one first. And if I want a solution, I can go with 0, -3, just right there. And I can go with -3, 0. That will add up to -3, as will any of the points I put on there. Now y equals -2x goes through 0, 0, and has a slope of -2. And our solution is 3, -6. There it is. It is consistent and independent. Let's see. Let's go ahead and just graph them. This first one, I'm going to let x equal 0, then y is going to be -1. Then I'm going to let y equal 0, and x will be -2. Notice how easy that is. I just substitute in, these are called intercepts, y-intercept and x-intercept. Now I'm going to graph the blue one. I'm going to go through 0, -3, and I have a slope of -1/2, and they are parallel, which makes them inconsistent. No solutions. This one, we'll graph the blue one first. Y equals -6x. It's going through 0, 0, and it's going to have a slope of -6/1. Very steep graph, isn't it? This one over here is going to go through -6x plus 2, which is going to go through 0, 2, and it's also going to have a -6 graph. A little hard to see that one, and a lot of people are going to look at those and say, oh, maybe they're on top of each other. They're not the same equation. Notice that they're 2 apart, so they are independent and inconsistent. Hard to tell, but they are parallel, of course. They have the same coefficient on the x, same slope, different intercept. All right, now I don't even have to solve for y, which is kind of a hassle. I can tell you already, because the coefficients on my x's and y's are the same, and the numbers on the other side are different, that this is a case of parallel lines. If you solve for y, you'll see why I get the same slope. So anyway, there it is. Let's go ahead and put them in. I'm going to use intercepts, if that's okay. And on my first one, I'm going to let x equal 0. In my head, I'm doing x is 0. And in my head, I cover up that x. And what I see is -y equals -4. So 0, 4 is a solution for the orange one. Now I'm going to pick another one. This time I'm going to let x equal 0. And y will be 4. And then I'm going to let y equal 0. And this time x is -4. And there it is. It has a slope of 1, doesn't it? If you solve this, you'll see that it has a slope of 1. Now the blue one says that if x is 0, y is -8. Oh, shoot. I didn't mean to do that. Sorry, guys. We're looking at -4 and 4. I got to get rid of that point. Sometimes I forget to click on the other equation. All right, so our first equation is correct. I just want to make sure I didn't mess it up. Now my second one, I'm going to let x equal 0 and y is going to be -8 for my blue equation. And this time I'm going to let y equal 0. And now x is going to be 8, isn't it? And we can see that they both have a slope of 1 and they are inconsistent. They do not have a solution. They're parallel. Okay, we're going along. In this one, I'm going to subtract the x from both sides in the first equation. And what you'll see is that we have the same slope. Another way to do this, and I kind of want you to see this because a lot of people don't get this. take a look at this first equation, x plus y equals 2. I want you to think of two numbers that add up to give you 2. How about 1 plus 1? 1, 1. That's a solution to this equation. So is 0, 2. 0 plus 2. And how about 2 plus 0? And how about 3 plus negative 1? And 4 plus negative 2, and so on. Hopefully you can see that I really like equations like that. Now this one is going to go through 0, negative 9, and it's going to have a slope of negative 1. That means it's going to go down 1 over 1. Now these are inconsistent because they have a negative 1 slope. They are parallel. Same equation. That makes them dependent, doesn't it? So we're going to go through, let's put it through 0, 5, and has a slope of 2. 0, 5, and has a slope of 2. 0, 5, and has a slope of 2. And we're done, dependent. Consistent and dependent. Infinite number of solutions on the line. Almost done. Hopefully fairly painless. All right. I'm going to go ahead and add 3 in my head to the bottom equation. And notice we're going to have x plus y equals negative 1 and x plus y equals 3, positive 3, because I have to add the 3 to both sides. Same coefficients, different numbers means they're going to be parallel. So it's a parallel situation. I'm going to go ahead and do the intercepts, which are, a lot of people like to think of the intercepts as negative 1 and negative 1. So I don't like to think of them that way because this point is 0, negative 1, and this point is negative 1, 0. Very different kinds of points. Now this one, we want the x plus y to equal 3. And I should write it, but x plus y is equal to 3. Here's what I did. 0 equals x plus y minus 3. I just added 3 to both sides. So x plus y equals 3. How about 1, 2? 1 plus 2 is 3. How about 1, 2? And how about 2, 1? And 3, 0? And 0, 3? And notice that they're parallel, which makes them inconsistent. There we go. Almost got it wrong. All righty then. Now what we have here, if I subtract 1 in the second equation, you can see that I could change the signs of everything. That's a very common kind of thing to do. Let me go ahead and I'll just do it that way. Now I could solve this for y. There's lots of things I could do here. I'm just going to use the intercepts in the first equation. So in this dark green equation, I'm going to go ahead and put in the intercept. So I'm going to let x equals 0, and then y is going to be 3. I just divided by the negative 1. If y is 0, x is going to be negative 1. There. So there's my first equation. Now my second one is a little harder to see because I'm going to go ahead and solve it for y. Can everybody see why I chose to do that? Hopefully you can. I had negative 3x plus y plus 1 equals 0. And I'm going to add 3x and subtract 1. So I'm going to have 3x minus 1. I just did this and this. And what I get is this. 3x minus 1, I can graph. It's going to be my purple equation. It's going to go through 0, negative 1. It's going to have a slope of 3. And darned if it doesn't look like they're parallel. They both have a slope of 3. And they are inconsistent. And we got a couple more. This is a situation where I have the same equation, and it may be a little hard to recognize, but I want you to notice if I multiply this top equation, if I multiply by negative 3 and negative 3 and negative 3 times all the terms, we call this a row operation. I'm going to multiply the entire equation by negative 3. And what I'm going to get is negative 3x plus 3y. Notice I have negative 3 times a negative y. And a negative 3 times a negative 3 is equal to 9. Same equation, same. So they are dependent. So let's graph them. For whatever reason, I like the green equation better than the purple one. Most people would say, no, 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 I like the purple one better. It doesn't matter. It's the same deal. So I'm going to graph it. I'm going to use the intercepts. I'm going to let x equals 0, and then my y is going to be 3, 0, 3. If it makes more sense to you to do it the other way, it's fine. I'm going to let my y equal 0, and in this case, my x is negative 3. So there's my green equation using the intercepts. Now I'm going to graph this equation in purple using the intercepts. If x is 0, y is 3, isn't it? And if y is 0, x is negative 3. Just right there. Notice they're on top of each other, and that's the dependent and consistent. And we have one more, it looks like. Oh, two more. Shoot. Same equation. I'm going to use intercepts. I'm going to do it fairly quickly. Let's do this one. If x is 0, y is 2. And when y is 0, x is 8. There's one of them. Here's the other one. Same 2 points because it's the same equation. Dependent and consistent. There we go. And we have one last one. And I hope you guys will try it yourself. I'm going to go ahead and solve it for y. Now be careful. If I solve this top equation, let me go ahead and bring it down here. There's some other things you could do, but if I solve that top equation for y, I'm going to have y equals 3x minus 6. Notice that I subtracted 6 from both sides. And for my blue equation, I'm going to have y equals positive 3x. I just changed the signs. In IXL, for whatever reason, they like to multiply by -1 on both sides. I like to divide by -1 on both sides. It's the same. It has the same effect, though. Changes the sign. So let's do it. Let's put in our final equations. We've got the orange one, and it looks like it goes through 0, -6, has a slope of 3. That's up 3 over 1. And then we do the blue one, and we go through 0, 0, and we go up 3 and over 1, and they are parallel, which makes them inconsistent. Notice that they both have a slope of 3, okay? And I hope you guys got it okay, and you'll do your practice and get your 100, get your mastery medal, and I'll see you back again. Bye.